Hello everyone and welcome to our stream today. It will be related to the 3D printing and how we use it in our research activities. Let's give several minutes for people to join and we will start shortly. Hello everyone, one more time. My name is Vasily Semkin and I'm senior scientist working at VTT. My main expertise is antennas and radio wave propagation measurements and modeling. And of course, I'm interested in drones as some of you already may know. And welcome to our stream. And today we want to give you some insights about how new technologies, how 3D printing can be utilized in your research work. And today we have also Kimmo with us. So Kimmo.
Hello everyone. So I'm working here as a research assistant and I have been helping Vasily with creating different 3D models and parts for our projects.
Okay, and Kimmo, can you give maybe some examples what or how we utilize 3D printing? Maybe it can be not only work related, but can you also just give some examples how you started doing 3D printing and how it evolved eventually?
Yeah, sure. So I began flying FPV drones when I was like, I guess 14 or maybe 16 already. And there I noticed that quite many things could be 3D printed to make life way more easier, at least in the aspects of the hobby. So for example, we have this like FPV drone model, and there is this 3D printed part for the GPS and video antenna. And then also nowadays we can even print like drones themselves. So here we have like a nano long range model found on Thingiverse, which anybody of you who has a printer or can use some other printer can print. So then in other aspects of life, you can use 3D printing for kind of like adapters. That's the most common use. So for example, like a coat hanger, which you only need single piece of, or maybe some part which is not sold anymore, but it's pretty easy to model. So for example, here we have this shelving, and we utilize it for our, like, for example, inserts, and well, it's pretty difficult to take it from there. But yeah, anyways, inserts and other things. And you can basically print any small items which you might need for something. So then,
Maybe
guess-
I can add here. So of course, you can do a lot of 3D prints in your home, and which can help to optimize your daily life. But at the same time, 3D printing can be very useful in fast prototyping. So when you need to manufacture something like some holders, for example, or something else, like for example, in this case, we have an antenna array, which we have designed here at VTT. And if you want to mount it on a drone for wireless communication, 3D printing actually would be a really fast way to do it and to mount it. And we have several examples actually how we utilize 3D printing. But maybe Kimmo can, while I just try to find the video and just put it online, so if you can describe what types of 3D printing there are and what are advantages and which we are using the most often.
Yeah, sure. So basically, in 3D printing, we have three main methods currently. So one of them is basically the extrusion method of printing, which we mostly use here at VTT, or at least in our drone team. So basically, you have this tool head which goes in a pattern and extrudes filament. Then there is the resin 3D printers, which utilize a display which only has, I guess, UV, like pixels. And with that, you have this layer, or like tooling table, which comes to the screen. Then there is like a layer which kind of solidifies under the UV light, which also is in some kind of a pattern. And that basically repeats for the whole model. And that method is way more accurate because the screen can be, for example, 8K screens. But the disadvantage is just working with resin, basically, because resin produces quite a lot of fumes, and it's most often not the easiest way of 3D printing and like rapid prototyping. But for small parts, for example, it's quite good. And then lastly, at VTT, we also have this team researching metal 3D printing. And there they use lasers to kind of solidify a layer of metal powder. And then they wipe new layers of powder on top of it and solidify it again. And all of these three ways of 3D printing have been constantly evolving and constantly adapting to the needs of the industry and people just even in their like spare time. So then, should we move on to how we utilize 3D printing in aerial projects?
Yes, but before that, I wanted to mention one of our projects together with the European Space Agency. And I will just put some short video to give you an idea how 3D printing was utilized here. So in this case, the primary use case was measuring the altitude, speed, and attitude of the spacecraft during entry, descent, and landing on the Moon on Mars. And the secondary use case was an orbit rendezvous with a passive object such as small transport container. So, and we developed a demonstration system using automotive radar ICs and also conical horn antennas. And basically all this structure, as you can see, we designed the 3D printed parts for it in order to mount it on the drone. And the drone is actually a very nice tool if you want to test something like to measure the altitude and speed and so on. And in this particular project, we mounted all the design parts on the drone itself. And then we made different flight tests and to verify the feasibility of utilizing FMCW radars as a landing modules. So here, for example, you can see our test or our flights in the field when the drone is flying and then the radar system is mounted underneath the drone. So, and all these parts, in order to mount it, as you can see, it's quite complex geometry. The 3D printing was utilized and there were multiple parts printed, and this allowed us to mount everything on the drone and do this quick prototyping, testing, and measurements. And as Kimmo already mentioned, so we have aerial project. This is joint project funded by Academia of Finland and National Science Foundation. and it is a joint project with New York University at London School of Engineering. And in that project, the idea was to develop a channel sounder and a measurement platform so that we can measure wireless channel properties between drones and ground robots, for example. And in that particular case, we have been developing hardware and software parts. And regarding the hardware, as you can actually see here on the table, so Kim will maybe show it closer on the camera, we have this modular system where all the components are mounted.
Yeah, and so basically the system, the idea in it is, like Vasily said, that it's modular. So we can exchange any parts and print different adapters or other parts to it or remove them from it. Of course, as a modular system, it takes a bit more space than a non-modular system, but for research purposes, it's usually better that we can just change parts pretty easily. So then it takes, for example, for this battery cage here, it took like a few hours to model, design, and then it printed overnight, and next day we could test fit it and see that it worked. If it didn't work, it would have taken a bit more time to just print the new model, but it's quite easy for rapid prototyping use cases, kind of.
And in this case, what we did so that we can also insert all the components and change them very easy. Exactly. So like modular system allows us if some components fails or if you have some issues, so they're easily replaceable. And here, as you can see, we have antenna array in the front of this structure, like here located. And it allows us to have beam steering so that we can steer the beam during our channel measurements. And we put all this 3D printed structure on a gimbal. And we have two nodes, one on the ground, one on the drone. And gimbal allows us also mechanical rotation of the system, and we can align it with each other. And now we want just to show you, also give you idea about aerial project itself. So enjoy this short video.
We are already living in smart cities where new technological services are constantly emerging. For instance, robot deliveries have become commonplace. You can order food or drinks to your home, and a robot will deliver them. Additionally, new technologies are enhancing urban safety. Unmanned aerial systems integrated with vehicles offer significant advantages. Drones can play a crucial role in assisting first responders, such as firefighters, paramedics, and the police officers, by providing them with real-time information. For example, a drone can fly ahead of an ambulance to monitor traffic conditions and suggest alternate routes to avoid congestion, ensuring that help arrives as quickly as possible. Similarly, drones can provide firefighters with aerial views of a fire, helping them assess the situation and plan their response more effectively.
We all know how important wireless communications is in your daily life. Imagine trying to go the whole day without your cell phone. Wireless communications can unlock all sorts of possibilities for drones as well.
Considering the mentioned applications, this project involves designing and building a channel measurement system that can be integrated into a flying vehicle. We are also developing custom software for data acquisition and equipment control.
Aerial is a project aiming at developing novel channel models at millimeter wave frequencies, and we want to study the communication between the flying platforms like drones, for example, and ground units, robots, cars and vehicles.
And this area of wireless characterization in the air is relatively unexplored, which is why this project is so important. We're setting the foundation of aerial wireless communication.
Fundamental is understanding how signals propagate, that is, how they move in the air and how they interact with other obstacles like buildings in the environment.
Another area where the results of our project will be valuable is in the integration and seamless coordination between drones and ground robots. The drone can monitor the situation on the street, detect accidents, or determine if assistance is required. It can then dispatch the ground robot equipped with a medical kit or defibrillator to the location, thereby supporting first responders and enabling faster delivery of medical supplies. Furthermore, This technology can be scaled and adapted for various emergency scenarios, whether it's delivering medical supplies during a natural disaster, assisting in search and rescue operations, or supporting routine emergency services.
Project Aerial isn't just about pushing boundaries. It's about erasing them and making high-speed, reliable communication a reality for drones everywhere.
So I hope you get some idea about our aerial project, and as I mentioned, we use 3D printing quite a lot there, and we will be actually doing more streams related to that project, and I hope you will join that streams as well, where we'll be showing real measurement campaigns and so on. But for now, if we continue to the 3D printing, Kimmo, could you please maybe go through various materials and their availability, and what is the main difference, and how do you choose material for 3D printing?
Yeah, sure, Vasily. So a 3D printing material spool or filament spool looks something like this. So this example is a flexible material, but we have all sorts of material here. So let's return back to materials in a moment. But before that, I want to show you the differences in infill percentages and the infill patterns. So what is an infill? Basically, infill is a way to fill the inside of your 3D printed part, because without it, it wouldn't be that rigid and you could break it quite easily. So here we have an example of a material which has 5% and 10% infill, and the difference is quite drastic. So then I can show you also the other variations. So here we have 15 and 20. This is 25, 30. Maybe I can place them a bit better. Let's see. Let's make it so it's visible to you as well. Yeah. Then we have 40 and 50. And it starts to become quite full at this point already. And usually we don't go this far. And last one is 80 and 90. So you can really see the difference between the first one and the last one here. Usually in our research, and even the usual recommendation I give to people, is to use 20%. For parts which need to be lighter, 15 is good, but 10 is usually already way too weak. So as you can see, the 10 one, it might still break quite easily. Then next to the infill patterns. So here we have rectilinear and aligned rectilinear pattern. Next one is triangles and grid. Then we have cubic and stars. Let's see. Yep. And lines and concentric. So all of these infills have different purposes, and I will show more soon. But the one which I often recommend, at least for people who are beginning 3D printing, is using a cubic, basically, pattern, because it gives strength in all directions, and because it's still kind of linear, so it prints in straight lines, there often is less risk of getting any issues with the print compared to the other one, which I will recommend soon when I will show it. So then there is lighting and zigzag patterns, Archimedean spiral and octogram pattern, Hilbert curve and gyroid, adaptive cubic and support cubic, and honeycomb and 3D honeycomb. But it's, you can almost see it. Let's see. Yeah, like this. So the other one I was speaking of was gyroid pattern, because in addition to strength, it also gives flexibility in all directions, since the pattern is kind of like a spring. But in most cases, it feels quite tough on the outside as well. But there will be slight differences if you have larger parts or parts which might flex in use. And to add to the previous statement, actually the adaptive cubic is the one which I recommend, because if you have a large empty part, basically like a cube or something like that, then the adaptive cubic will not print infill in the middle, which is kind of not needed. Some infill patterns are more so for like decoration uses. So for example, with these two, you could do some like, I guess, not cup holders, but can you say, Vasily, the thing you put under like a ale cup thing?
Yeah, I see. So if you have a hot drink and you put it on the table, basically
yeah.
that one, yeah.
Yeah. And then lighting is quite useful if you want an extremely light part, which has most of the like structural strength coming from the shell. So shell is kind of this part here on the outside, or rim. So then you will have way less infill basically in the part. So then, next I could probably explain to you how to orient your parts. Or do you have something to add, Vasily?
Yeah, actually, maybe I wanted to ask just how do you choose the infill, even though you already mentioned it, infill patterns and infill percentage. So what would be the main recommendation for general prints, for lightweight prints, for rigid prints?
Yeah, so like I said, for general prints, I usually recommend 20%, which is quite common in like 3D printing communities. For light prints, you can go to as low as 10, but there might be then some issues with like overhangs. So for example, if you are printing this part like this, I guess like this, so standing up, then using 10% might kind of not support the roof of the part itself. So there will be like large gaps in that direction. Of course, you can mitigate that with the patterns. So if you use gyroid or use cubic subdivision, then you can mitigate the issues. But still, with too low of a percentage, you will not have a like smooth roof on top of your part. Then for like use cases where the part needs to be very rigid and the weight is not of concern, I wouldn't go higher than 50. Or then if you actually need to go higher, then I would just print at 100%. Because with the extremely tight patterns, which I can show here, usually there will be different issues with the printing process itself, because the new like material will go over already printed material, and it might cause issues with the extruder itself at some point if it starts eating away the material, because it will try to push material where it just can't, basically. Yeah. So.
And, yes, and then how do you orient 3D printed structure? So when you put it to the printer, does it really matter which direction you print? And if yes, how do you define it?
Yeah. So basically, the orientation in which you print matters quite a lot. Since 3D prints consist of layers, most of the main methods right now use layers. Of course, with metal printing, it's a bit different, but it's close enough. And with layers, basically, the strength, most of the strength is in the direction of the lines. So if I print this way, like this part is printed, basically. So it was flat on the printing bed like this, and thus the layers are going in this direction. So it's quite strong in this direction and flexes a bit, but it doesn't break that easily. But then if I would have printed the whole part standing up, so basically if this is the print bed, and this, or I can use this to simulate. So if this is the print bed, and this is the part I'm printing, so it's standing up, then it would be extremely weak as a part, because then it would just snap if I would fold it like this, because the lines would be here, and the lines themselves are not that strong. So most often you want to design the parts in a way where the structural, or like it's printing in the, basically the part which is flat on the print bed is also the like layer in which you want it to be strong. So for example, the box I made for containing these parts was printed this way on the bed, so I didn't need any supports, and that's often taken into account in designing these parts. So this didn't need any support, and it's really strong in the direction where it needs to be strong. So because you will not like snap it like this, because there is too little of basically distance here to snap with brute force. But if I would have printed it this way, then all of this would have needed to be support to basically support the roof and all of these small racks here. And then it would snap quite easily if I just folded it like this.
So of course, yes, the orientation plays quite a big role, and you should just take it into account. But I think you can also use support structures when you do very complex geometries, and when you have some overhanging like parts, then you can use various support structures.
Yeah.
But let's give Kim a moment. We also wanted to show you a workflow. How do we do the whole design of the 3D printed part? How do we print it? And just give you an idea what use cases it can be. So in this particular, while Kim was preparing his laptop, I can just show you on this camera. We made a 3D printed box, so Kim designed this box. It was done for the FPV camera so that it also can hold a receiver inside it and also have a fan to cool down the FPV camera. And the idea was to utilize this kind of box or this system so that we can attach it to the drone, so that we can attach it also to our payload and switch between multiple views which will be useful for the pilot and also for the payload operator. So in our measurements, when we do, for example, channel measurements in this particular case, as you can see here, so it's very important also to align the receiver and transmitter, and in this case we want also to have video as a reference. So for example, when we start processing the channel measurement data and something is wrong, we want to understand why, and usually these recordings from these cameras is quite useful. So Kim, are you ready with this 3D printed workflow?
So with the workflow there are a few issues. Let's see if they can be...
I can give you this connection.
Sure. But it seems the issue probably isn't with the connection. Let's see. But I can probably show the other parts, and then at the end I can maybe try to get this to work. Let's see. Just a second.
But yeah, besides giving you ideas about 3D printing and explaining all these, of course, we would be also curious to get your questions, which we will take in the end of the stream, and also maybe to know how do you use 3D printing in your work or maybe even in your hobbies. So.
Yeah,
let's go with the process slicer.
Yeah. So basically, the workflow starts in a 3D model software. There is IronCAD, which we have used here in VTT. Then we have SolidWorks, and one of my recent favorites is Onshape. The reason why I like it is that it's basically online, and you can share the files pretty easily with just a link, because that has been one of the issues with traditional 3D modeling in the industry, that often it takes time to send the files back and forth and edit them basically on multiple computers, while in Onshape you can edit it at the same time with other people. But I'll probably show it later on, but after you have modeled your file, you of course need to download it, but you usually don't download or just save the CAD model. So CAD is a computer-aided design, and most of the 3D modeling softwares are CAD softwares. And so you don't just save the CAD file, but instead you need to export some 3D file which the 3D printer slicer can read. So one of the most popular currently is STL files. And here we have, for example, 3 files which are of this camera here. And they're downloaded and ready here. So after you have the files, another file format, or few of them which are also quite popular, are OBJ and then 3MF. Yeah. And then basically, after you have downloaded the files or exported them, you need to put them into a slicer. There are a few slicers out there. Prusa slicer is the one we use here at VTT, but then also Cura for Ultimakers is one, and then Bambu has their own. I'm not certain of the name, but yeah. So in Prusa slicer, we import the models, then we need to orient them. So for example, this model part here was already, at the beginning standing like this, and I just needed to turn it in a way where I could print it without supports, because otherwise we would have supports here. And I can actually demo it. So if I enable supports here, for example, and I can change them to organic, so it would be a bit more interesting. So let's do that. Organic here. So then if I slice the model. So slicing basically is the part where the 3D printer the software, sorry, makes the files usable for the printer. So it defines your printing layer height, which most often we use 0.2 millimeters. And after that, it goes through the 3D model and sees what do the different like heights contain, and change them into G code or binary G code, where basically the printer now knows where to move the nozzle at different points of time. And here we see the supports, and basically this is the reason why we don't want to print the part oriented like this. Firstly, the like upright part is quite thin, so it will snap pretty easily. And also removing supports always takes some time, and if it can be mitigated in the design stage or kind of the slicing stage, that will be also quite good. So now if we reorient it back to how it was, basically, now we can print the whole file without supports. So one example of designing for no support use is this grid, which I made back here. So basically the angle of these lines is higher than 45 like degrees. And with that, the part doesn't need any supports. Of course, you see the blue mark here, which kind of means that it's a overhang, but it doesn't matter because the part is so small that the like new 3D printed layer will not start to sag in that time. But if it would be a larger distance, then supports would be needed. And now we can check the infill. So if I scroll this kind of history graph, we can see how the infill is building up inside of the part. So this infill here is just a grid, which is the default in Prusa Slicer. So usually before slicing, I go into the infill settings and change it to, for example, let's go with gyroid. But often I have my own templates which have all of this already built in. So the layer height, the infill, maybe supports, other things regarding that. So let's see. It takes a bit to slice, and then it should be ready. Any minute now. Do you have any questions, Vasily? Meanwhile,
but now I just want to add here that once you make your 3D design and once you upload the models into the slicer, you can actually get the idea about different layers, about the problems which can be during the printing. So this is the first way to make an estimate and like to see if your printing would be successful. But actually, since we wanted to show you the whole workflow process, and but it takes some time to print this structure, so it's maybe like a couple of hours, I would guess, but it also depends on your settings. But here is how the printing process will look like once you upload the file to the printer. So it just starts printing layer by layer, and as you can see here, we have like base layer, which is maybe the crucial one, so you should always check how your base layer appears to be. If there are no issues, most likely your print will be successful. And then here you can see how we get this box for the FPV camera printed layer by layer. And then, of course, once it is done, so we install all the components into the box, and as you already have seen, like the camera box which we were showing in the beginning. So Kimmo will show it one more time here and how everything is installed. So here is the final printed version of that box, and with already installed components inside. And then we just close it, and then as we were showing you, and as you have seen in that aerial project video, then we install that camera box here on the payload, so that it's just aligned with our antenna array, and we can get reference video when we do measurements. I would say that this was like maybe the main. These were the main things which we wanted to cover. I would suggest that I will check Q&A if you have any questions, so we can go through the questions and just describe what our viewers are interested in. But while I'm checking the questions, Kimmo, could you please tell where, for example, of course, I understand if you do prototyping, you do it in the CAD design, but are there any sources where you can find the 3D models?
Yeah, sure. So for the sources of pre-made files, which is kind of the way with which I also started my 3D printing hobby. So one I used at first was Thingiverse, which is, I guess, owned by Ultimaker, or their parent company basically. And then one which I have been using more recently is Printables. So there is differences between the sites. They have differing algorithms, I would say, and currently I would probably recommend Printables more, just because most of their 3D models, I would say, are better designed, even though they don't have, basically it's both of the platforms are public, so anyone can share the files, can upload them there, use them, and as such. Maybe should I show the website or?
No. Yeah, I think it's fine. I think we can actually leave all this information in the comments, but I would also add, maybe there are plenty of websites which you can use for 3D designs. There are free models, there are paid models, for example, like a lot of authors do, like their own designs and sell those models also. And of course, you can search for those as you wanted. So I just checked in the chat. We have one question for now about suggestions to start 3D printing. So maybe I can take this one. If you want to start 3D printing, as we were saying, so you can have already a lot of available models, and nowadays the 3D printers, they are not very expensive, so you can buy a very cheap printer actually, and just start using and experimenting with different filaments. But of course, when you go to professional use case, you can use more sophisticated setups and printers, and more with more precision and so on. In our case, as Kimmo was mentioning, software, it's yes, we are using that right now, but not limited to that one. So of course you can use any other software. It's maybe also some personal preferences and so on. And of course, printers, there are a lot of available printers, as I was mentioning, starting from very cheap to going to very expensive and industrial printers. And as also we were mentioning in the beginning of the stream, we have a specialized team at VTT who are developing 3D printing methods and 3D printing technology itself. So if you're interested, we can also leave in the comment the information about them and link to their work basically. But anyway, if we will have our contact details available under these videos, so Kimmo's and mine, and if you have any questions later on, feel free to join and to join our community and ask our questions. And of course, don't forget to subscribe to the channels, to our profiles, and follow, because we are planning a lot of new streams related to our work and our workflow process, everyday workflow process as a researchers. So do you have anything to add, Kimmo?
Probably no, not at this moment. There is always more details we can give out, but it's already running pretty late, so.
Yeah, so it can be it can be very long discussion, so we will take it offline then. But thanks for joining, and see you soon.